Okay, hi everyone, it's Professor Sebastian back to our statistics class notes on page 74. And so we just were playing around with stack crunch and we were just rolling two dice. And I just wanted to actually get you to understand that we can really determine these theoretical probabilities pretty easily. So I created this little table for you to see that. So pretend that we have the first die, and that first die has a 1 on it. Now the options that go along with that for the second die are a 1, a 2, a 3, 4, 5, or 6. So when you add those up, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, 1 plus 5 is 6, 1 plus 6 is 7. Okay, so if the first die is a 1, then between getting a 1, 2, 3, 4, 5, or 6 on the second die, your sum is anywhere between 2, 3, 4, 5, 6, and 7. Now, if your first die is a 2, and you can get a 1, 2, 3, 4, 5, or 6 on the second die, then your sum is going to be anywhere between 3, 4, 5, 6, 7, and 8. If your first die is a 3, and then on the second die you get a 1, 2, 3, 4, 5, 6, or 7. So for example, 3 plus 1 is 4, 3 plus 2 is 5, etc. You get anywhere between 4, 5, 6, 7, 8, and 9. If your first die is 4, here's your options for your second die. You get anywhere between a 5, 6, 7, 8, 9, and 10. If your first die is a 5, then your options for the second die again, 1 through 6, gives you the sums of 6, 7, 8, 9, 10, or 11. And if your first die is a 6, and your second die with all of its options, you can get anywhere between a 7, 8, 9, 10, 11, and 12. So what's the probability of rolling a 2? Well, there's only one. Now, if you notice, there are 36 possible combinations that you can get between two die. Now, the easiest way to think about it is 6 on the first and 6 on the other. So 6 times 6 is 36 possible ways that these sums can happen. Only one of those 36 where you get a 2, where the first die has a 1 and the second die has a 1. So 1 out of 36. To get a 3, there are two ways you can get a 3. Either get the first die has a 2 and the second die has a 1, or the first die has a 1 and the second die has a 2. So there's two ways to get 3. So 2 out of 36 is 1/18. There are three ways to get a 4. So 3 out of 36 is the probability of getting a 4, which can be reduced if you want to 1/12. There are 4 ways to get a 5, that means 4 out of 36 ways to get a 5. So there's 1/9 probability of getting a 5. There are 5 ways to get a 6. So there's 5 out of 36. That's the probability for rolling a 6. There are 6 ways to get a 7. So it's 6 out of 36, or 1 out of 6 probability of getting a 7. By the way, if you like to play craps in the casino, which I do if I ever go to the casino, that's my favorite game. Rolling a 7 is only good for the roller on coming out, but it's bad for you most of the time, and the house wins everything. So you can see how they rigged that, where that's the most likely thing to happen, and so that's of course theirs. And you can work that way back down. You can see what all those probabilities are. So it's kind of interesting. And I showed you a simulation, right? I showed you a simulation where you got these probabilities. Okay, so these don't come out to be exactly equal to, right? I ran these 3,000 times. I ran a simulation of rolling two dice 3,000 times. And with these probabilities, you can see that they don't exactly equal what the theoretical probabilities are, but they're pretty darn close.